A patient is admitted to the hospital for treatment of metastasized thyroid cancer. The prescribed treatment is to swallow a pill that contains 11 units of iodine-131, a radioactive isotope with a decay rate of 8 3/10% per day. In accordance with United States regulatory guidelines, the patient cannot be released from the hospital until no more than 1 2/10 units of iodine-131 remain. How long will the patient stay in the hospital? Write an equation and approximate the solution graphically. They already give us the equation here on the graph, so it's d of t equals 11 times 917 thousandths raised to the t power. And so using that, then how can we solve this equation? Well, our question is, how long will the patient stay in the hospital? And we know that they'll be released when there's no more than 1 2/10 units of iodine remaining. And so that would be the final amount, which would be d of t. So t would be the time that they're in the hospital, and that's what we're trying to find. And d of t is the amount of iodine 131 remaining in their system. And so we could just replace 1 2/10 for d of t. So basically this just means that our dependent variable or our y variable in our graph would be equal to 1 2/10, and we want to find the intersection of that with our function. And so to do that, let's go ahead and use our calculator. Okay, so in our calculator, then we want to find the intersection of 1 2/10 and our function, and so we can just put 1 2/10 into y1 and then the other side into y2. So I've gone ahead and done that, and I went ahead and I just used x for, instead of t, since x is, it's already a button here on our calculator. And so now, just going to graph, then we can go ahead and find this intersection. So pressing second trace, then 5 intersect, and then press enter 3 times. Then we see our answer is x equals 25 and quite a long decimal, and then y as expected is 1 2/10. And so this is the number of days that someone's in the hospital. And so most likely we're going to round that up and just make sure that they really have reached that level of iodine 131 that they need to be at. So rounding up, that would just be till 26 days. They most likely wouldn't keep them for 25 and 0.56 of a day. That wouldn't make as much sense. So our answer will just be 26 days that they have to stay in the hospital. Let's go ahead and summarize. The model d of t equals 11 times 917 thousandths to the t can be used to write the equation whose solution yields an answer to the question, is 1 2/10 equals 11 times 917 thousandths to the t. Solving this equation predicts that there will be 1 2/10 units of iodine 131 remaining after 25 and 57 hundredths days. Therefore, the patient can leave the hospital after approximately 26 days.